All right, guys, so we're looking at our notes from 1.3 Part 4. We're talking about evaluating limits using our three different methods. Now, the first method that we should always use is a numerical method. A numerical method just means we're going to plug in the value. But some things can happen when we plug in the value. Actually, there are three possibilities that can happen when we plug in a number. Here's the first possibility. Possibility number one. You get a constant. If that happens, good news. You are finished. Because the limit equals that constant. So that's what we hope happens. That we just plug it in, we plug in a number, we get 5, we get 8, we get 0, we get a half, whatever. That's going to be our answer right there. But life's not always so easy. The second thing that can happen is we get a constant divided by 0. If that happens, it's pretty good news, because what that means is the limit, anybody know? Does not exist. We'll just abbreviate that, D and E. So if we get 5 over 0, 10 over 0, 100 over 0, the limit does not exist. But what if we get 0 over 0? 0 over 0 means we have to do more work. So then we go to step 2. What's the more work we can do? Well, there's a lot of different analytical methods we can use. Analytical just means algebra. Some of you were saying factor. Yep. We can try to factor. Another thing we might have to do. Can you think of anything else we do sometimes? Okay, simplify by using conjugates. You know how sometimes we multiply by the conjugate? So if there's radicals, we use the conjugates. Another thing we do, maybe you're not good at factoring. What can you do if you're not good at factoring? What's another way to simplify? Yeah, we can do synthetic division. So if you can't factor, go ahead and use synthetic. Another thing we can do is just multiply it out. Sometimes that's our only option, is to multiply it out. So we have all these different analytical methods, but we're only going to use these analytical methods if we get 0 over 0. We're not going to start off by trying these. We're going to start off by just plugging in the number. Only use these if necessary. Now, if we can't figure it out numerically or analytically, then we might have to use graphing. And on that, we might want to use our calculator. Now, if I'm taking a quiz or a test and I am allowed to use that graphing calculator, I'm going to use it to check everything. But here's the downfall with using a graphing calculator. Suppose the limit answers radical 2. You have to give me the exact answer. The calculator is going to tell you that it's 1.414 ... So the calculator is going to tell you this is your limit, but you have to give that answer. So you would lose a point because the directions would say give the exact answer. So that's why you have to know how to do problems analytically. All right, so let's look at some of the problems now. So I want you to try number 1. Remember, the first thing we try to do is what? Just plug it in. So everybody plug it in and tell me what you get. Does not exist? Do we agree? All right, you are correct. We plug it in, we get 2 over 0, does not exist. Wonderful, we're finished. Number 2, we're going to try plugging it in. Try plugging it in. What happens when we plug that in? 0 over 0. Have to do more work. So if we have to do more work, we might want to try factoring this, but What do you guys think? Do you know how to factor it, or do you prefer the synthetics? Okay, so some of you know how to factor it. If you do, great, go for it that way. Those of us who don't know how to factor it, what do I put in the little box? Conrad, what do I put in this box? 2. And then I use my coefficients, 1, 0, 0, -8. I bring this down. I multiply, I add. I multiply and add, multiply and add. So this is what's left over. But what does this mean? Good, Michael. Okay, so it means this. So now we can plug in the 2 without getting the 0 over 0. And Michael, what's the answer going to be then? I don't think so. 2 squared plus 4 plus 4. 4 plus 4 plus 4. Try again. 12. So our limit equals 12. All right. Number 3, we looked at it. We try plugging in. We get 0 over 0. What's the kind of more work we have to do on this one? Andy, what do you think? There's a radical in it, so that means you're going to use the conjugate, yes. So the conjugate means I'm going to write it exactly as it's written, but I'm going to change the minus to a plus. That's what the conjugate means. All right, so keep the limit going. Multiplying the first times the first. Well, our radical is just going to disappear. We get x plus 9. What always happens when I do the outers and the inners on conjugates? They cancel and give us 0 because one's going to be positive, one's negative, and they're exactly the same thing. So now I go to the last times the last. That's going to be negative 9. In the denominator, we're just going to keep it. Don't multiply it out. You only multiply out the conjugate part. If you start multiplying this out, it's going to get really ugly. In fact, it's just very difficult to even do that. So now, simplifying this, 9 minus 9 is 0, so I'm going to have x over. People always ask, do I have to write this every single time? Really, you should have correct notation, but I'll just let you put the arrow. These cancel, we're left with a 1. Our whole goal is to plug in 0 for x. Anybody done it and have the answer for us? 1/6, right? We plug in 0, square root of 9 is 3, plus 3, 1 over 6. Very good. All right, try number 4. Think of the first thing you do. Brooke, do you have it? 0. You get 0, right? Do I have to do more work? No, the answer is 0. That's a constant. We are finished. Did any of you start trying to factor it? I hope not, because you got an answer. You do not need to factor unless it's necessary, unless you get 0 over 0. All right, number 5. Try plugging it in. I get 2 minus x squared minus 2 plus x squared. That's 0 over 0. Have to do some more work. What would be the work that I should do on something like this? Here are my choices. What am I going to do? Factor, conjugate, synthetic division, multiply it out. I have to multiply this one out, don't I? Because I have x plus delta x, quantity squared. That's the part that needs to multiply out. Now, don't make a rookie mistake of saying that this is x squared plus delta x squared. It is not. You have to multiply that out as x plus delta x times x plus delta x. You got to FOIL it out. So the 2 stays the same. Minus. Multiply this out. X times x is x squared. The outers is x delta x. The inverse is x delta x. So what's that going to give you then? If I get an x delta x plus x delta x. Keegan, what is it? 1x delta x plus 1x delta x is 2x delta x. And I have to keep it in parentheses too. Then I'm going to do the last times the last. Delta x times delta x. What is it, everyone? Delta x squared. Now, I'm going to go ahead and distribute this negative through. All of this was just that right there. So now I'm to this part. I have minus 2 plus x squared. Just distributed out my negative. Everybody with me now? All I did was I squared this out. That was equivalent to this. I have memorized that as quickly as possible because it's just always going to come up. X plus delta x quantity squared is x squared plus 2x delta x plus delta x squared. If you can memorize it, you don't have to go through and FOIL it every time. All right, so keep going. We've got our limit still. We're going to distribute that negative. So I have 2 minus x squared minus 2x delta x minus delta x squared. We've got this. So now I have to figure out what's going to combine to be 0. Hopefully a lot of it will, because that's going to make the problem easier. So 2 minus 2, that's 0. Negative x squared plus x squared, that's 0. So now I'm just left with this. So if I have this and these two terms, what can we factor out of there? Delta x. So I still have my limit. I have a delta x, and I'm going to have negative 2x minus x delta, minus delta x over delta x. Now we can get rid of these, and that's good because my whole goal has been to get delta x to be 0, and now I can finally do that. So what's the answer to this limit going to be then? Negative 2x. Questions? All right, number 6. We look at this, we see this 5. We should pull the 5 out in front. You can always do that with constants. Constants are numbers. You cannot pull out variables. This is one of those special limits that I told you had to memorize. If you go back and look through your notes, do you know it? 1. So this is just 1, so it's going to be 5 times 1, so our limit is 5. Easy enough. For number 7, I factor out the 6. So this is going to be 6 times. Do you remember this limit without looking back? You have to know it. 0. What if you're taking a quiz, though, and you just don't know it? What could you do? Graph it on your graphing calculator. It'll show you that limit. Okay, if I'm taking a quiz and I don't know what this answer is, I put it on the graphing calculator. Remember, that's our third resort. We use that if we don't know what to do. All right, any questions on this page? Let's go over to the back now. All right, so sometimes our limits are more in like a graphing form. So I'm graphing this function. G of x equals x squared plus 4. Well, I know that's a parabola that's been shifted up 4 units. So I'm going to have like this. I don't use the parabola, though, when x is 1. That means there's a hole in the graph there. So 1 squared plus 4 is 5. There's going to be a hole in the graph right there. And then when x does equal 1, I have to plot the point negative 3. So here's the way this graph's going to look. By the way, this right here should be up here, so let's move it. Okay, so find the limit as x approaches 2. That means that we're traveling along this parabola, we're getting closer and closer to an x value of 2, And what's the y value we're approaching? What do you think? As we get closer and closer to 2, what's the y value we're approaching? Michael? 5. So this answer is 5. No, it's not. Sorry. As we approach 2, I was pointing kind of to the 1, but as we approach 2, the y value we're approaching, 2 squared plus 4, is going to be 8. All right, Michael, the limit as x approaches 1 is going to be 5, right? We were thinking ahead. And this one says to find g of 1. That means where's the closed dot? So that's saying when x is 1, what is the actual function's answer? Everybody, what's that going to be? -3. All right. You're also going to have this type of problem on your quiz. We did this type. It looks very confusing when you first glance at it. But remember how I said if you just do what you think you should do, it's going to be correct? So we have the limit as x approaches c of f is 6. We have the limit of g of x as x approaches c is -1/2. So if we're trying to do the limit as x approaches 3 of c rather of 3f of x plus g of x, what do you think we have to do with the 6? Just multiply it by 3. So it's going to be 3 times 6 plus -1/2. So that's 18 minus 1/2. That's 17.5. For this one, do what you think you should do. -3 times the limit of f of x, which is 6. So it's going to be -3 times 6 over 2 times g of x, which is -1/2. So that's going to give us -18 over -1, and that's going to be 18. Okay, this last problem is not on your notes, but it's something that you need to be able to do for the quiz, and it's kind of complicated. So you want to find the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x for f of x equals 6 over x. Now, pay close attention on this one. This is a difficult type of problem. You've got to go back and forth between what they're asking you to do and what the function is. So I'm trying to do this problem based on this f of x. So I'm going to write the limit as delta x approaches 0. So check, I took care of this part. Now I have to do this right here. So f of x plus delta x. Well, here's my f of x function. F of x plus delta x means wherever I have an x, I have to replace the x with x plus delta x. So what's it going to be then? This is going to be just 6 over what? What am I replacing x with? Not just delta x. X plus delta x. That's what this is right here. Wherever I have the x, here I have the x, replace it with x plus delta x. So I did this part now. Now I have to put minus f of x. What is f of x? 6 over x. So write that down. So now I did this. Now I have to put this bar. And then on the bottom, I'm going to put delta x. That's our setup. Okay? So now that we finally have the problem set up, now we're going to plug in 0 for delta x. Well, that's going to give me 6 over x minus 6 over x. That's 0 over 0. So what is a method I can do if I got 0 over 0? I'm not sure we even wrote this one down. We might need to add it. Yep, let's do add it. Squeeze in a number 5. Multiply by the common denominator. Multiply by CD. Actually, it's the least common denominator, but I think we would all do that automatically. So that's another method we can use, is to multiply through by the common denominator. So here's my denominator of x. Here's my denominator of x plus delta x. That's what the common denominator is. It's an x and it's an x plus delta x. If that's what I'm going to multiply by on the top, I also have to multiply by that on the bottom. So now I've got the limit as delta x approaches 0, distribute it through. Don't multiply it out though, because we want to get things to cancel. Okay, so there's the top. See what I'm doing? I'm multiplying 6x, x plus delta x, and then minus, and then 6x, x plus delta x over x. And then here, I'm going to put this x first, just so it's not confusing. Now, if we have done this correctly, then a lot of things should cancel out. All right, so looking at this first one, see how on this one, x plus delta x cancels? We're allowed to do that. What about on this one? What's going to cancel? The x's. So now what I've got is 6x minus 6 parentheses x plus delta x all over this. Questions on that? What do you think you're going to do next? Here's what I see people do. They cancel these two. You can't do that, guys, because this is not a factor. It's 6x minus 6 times this. You cannot cancel those two. So what do you have to do instead? Multiply it out. So come up here. Okay? So what's going to happen? Okay, 6x goes away because that's going to be 0. And so now we've got negative 6 delta x over x delta x. So now it's okay to cancel, isn't it, the delta x's? Because all we have, this is all gone now. So we've just got this over that. This is now multiplication, so I'm allowed to cancel the delta x's now because it's all multiplication. So now we've got the limit as delta x approaches 0 of negative 6 over x times x plus delta x. So now I'm plugging in 0 for delta x. So what's the final answer going to be for this limit? Negative 6 over x squared. Make sense? It's tough, and if you got confused on any of it, you can go back and watch this and watch just this problem again, if that's the only thing that confused you. That's one of the complicated ones on the quiz. All right, guys, way to hang in there. That was a